Alrighty, guys, here's part 2 for your assignment for the week. Now, we already learned how to figure out the number of valence electrons in an atom. Now, the next thing that we need to do is you need to be able to sketch the the electron dot structures for different elements or for different atoms. So we're going to do that. In order for you to be able to do this, you have to know how to determine the number of valence electrons. So if you haven't watched the video where we show how to do that, then you need to go back and watch that first. Otherwise, you're going to be completely lost. Well, somewhat. Anyway, here we go. Let me go ahead and switch to presentation mode so you can see what I'm going to be doing on the board. And the first question that pops to mind and that pops in the assignment is, what in the world are electron dot structures? That is a good question, Mr. Barajas. So electron dot structures, let's write it down on the board. Electron dot structures. That's an R there. Those are basically an element symbol and dots around it. So a symbol and dots. And those dots are the number, basically they are the valence electrons in an atom. So the dots are the valence electrons. In that atom. For example, let's sketch the electron dot structure for the element of magnesium, Mg. Okay? How do we do that, Barajas? Okay, we already have the symbol. That's Mg. Okay. How many valence electrons does Mg have? Okay, there is a long method of doing it. You can sketch the Bohr model and figure out how many dots are on the outer layer, or you can just look at the Roman numbers located in most of the periodic tables. And in fact, on the periodic table that you have in Canvas that I've shared with you like 20 times already. Anyway, so magnesium. Let's look for magnesium in our periodic table. Magnesium. Let me go ahead and undo all those lines that we don't need there. I guess that's not going to work. Real quick, let's erase them. There you go. Okay, so magnesium is right over here. Let's look for the Roman numerals. And the Roman numerals are right over here. And we have to ignore the letter A. II stands for 2. Okay, so if II stands for 2, that means there are 2 valence electrons in an atom of magnesium. So let's go back and let's remember. Let's write it down real quick. There's 2 valence electrons, VE for valence electrons, for an atom of magnesium. And according to our definition, it is just a symbol, the chemical symbol, and the number of dots, which there's 2. There's 1 dot and there's 2 dots. There. That's the electron dot structure for the atom of magnesium. Now, the dots, they don't have to be where I place them. They can be anywhere next to the symbol. If I wanted to, I can delete it. Let me delete that real quick. And I could place them right here. They have to be paired, but you put them right there. Okay? Let's do another one. Now let's sketch the electron dot structure for the element chlorine, Cl. Okay. Well, Mr. Barajas said that if I need to sketch the element or the electron dot structure for chlorine, I have to write down the symbol and then figure out how many dots. So that means how many valence electrons that one has. So let's look for chlorine in the periodic table and let's find that Roman numeral that will help us. So chlorine, where is chlorine? Oh boy, that periodic table is completely written on. So let's erase that stuff. Okay, chlorine is, right here. How many valence electrons? Let's go all the way to the top and let's look at the Roman numerals. And the Roman numerals, again, ignore the A. VII stands for 7. Oh, okay, so it stands for 7. That means there are 7 valence electrons or 7 dots around the element symbol. So there should be 7. There's 1. There's 2. There's 3. There's 4. That's parent. There's 5. There's 6. There's 7. And again, the dots, they don't really have to be exactly as I have them. You could have easily done chlorine, and then you could start your 1 right there, 2, 3, 4, 5, 6, 7. If I can count. Yes, that's 7. So it really doesn't matter where you put them as long as you pair them. These guys are in pairs. This guy is in pairs. This guy is also in pairs. And that guy is lonely. But anyway, the electron dot structure for chlorine is that. All it is look for that Roman number, Roman numeral. That's the number of dots around the symbol of the atom you're supposed to determine the electron dot structure for. Okay? So if this helps, fantastic. If it doesn't, please send me an email, make a phone call, or whatever. Get a hold of me. Now, this is how you determine the electron dot structures for various elements. Please go ahead and make sure that you watch this video as many times as needed so you can complete part 2 of the assignment that has been assigned to you. Okay? All right. If you have any questions, let me know. Have a wonderful day, guys. It's kind of weird recording yourself. So anyway, I hope this video was helpful. And still, I can never get it right the first time. This is probably the 3rd time I'm recording this one, and I'm hoping it's good. Anyhow, that being said, you guys have a wonderful day. I am trying to figure out how to cancel this guy from recording anymore. There, stopping. 1, 2, 3.